Hello everyone, welcome to Vanilix AI. At Vanilix AI, we empower business with generative AI, AI agents, automation and cloud AI infrastructure to drive digital transformation and create real-world impact. Today, I will be walking you through ClickHouse Text-to-SQL using Ollama Llama 3.1 and explaining how these technologies work together. The main idea is to allow users to interact with database data using natural language instead of writing SQL queries manually. When a user enters a question, Ollama Llama 3.1 understands the request and generates a valid ClickHouse SQL query based on the database schema. The query is then executed on ClickHouse and the results are displayed through a Streamlit web application. Now let's go through the architecture diagram. Marketing data sources. The workflow begins with multiple marketing data sources such as Google Ads, Meta Ads, LinkedIn Ads, Website Analytics, and other CSV API files, etc. The systems continuously generates the business data. The collected data flows into the injection layer through the API connectors. The ETL and ELT pipeline using Airflow, Perfect, Daxter extract, clean, validate, transform, and load the data. After processing, the cleaned data is stored inside the ClickHouse. Raw data is transformed into process tables and materialized view, allowing high-performing analytical queries. Semantic layer. This is an intelligence layer of the application. When the user asks a question in a natural language, the Ollama Llama 3.1 model converts it into an optimized ClickHouse SQL query. Metadata and scheme context. To generate accurate SQL queries, the LLM requires complete knowledge of the database schema. The metadata layer provides the information about the tables, columns, and relationships and description. This is the user interface. The generated SQL query is executed on the ClickHouse and the results are displayed through a Streamlit web application. Users can also download the results as CSV files. Monitoring. Finally, workflow orchestration, monitoring logging, and altering ensure that the entire data pipeline runs reliably. To summarize, the application collects the business data, processes it through an ETL pipeline, stores it inside the ClickHouse, generates the SQL queries using Ollama Llama 3.1, execute those queries, and present the results through an user interface. Let's now look at the project structure. This app folder contains the main Streamlit application along with modules responsible for SQL generation and execution. This tools folder contains the reusable modules to keep the project modular and maintainable. This ClickHouse connection.py. This module creates the ClickHouse database connection, and this Text-to-SQL.py. This is a core AI module. It retrieves the database schema and sends both the schema and the user question to Ollama Llama 3.1 to generate the SQL. This executes SQL.py. This module executes the generated SQL query on ClickHouse and returns the result. App.py. This is a main Streamlit application responsible for the user interface. This main.py file provides a command line interface for testing. This data folder contains the sample sales dataset used in this project, and SQL folder contains the create database SQL and the analytics queries.sql, and the requirement.txt file contains list of all the required Python dependencies, and readme file contains the project documentation and setup instructions to it. Now let's start with the database connection module. This file is responsible for establishing a connection with the ClickHouse database. First, we import the ClickHouse client library, which allows Python to communicate with the ClickHouse database. Instead of hard coding the connection details, we read the host, port, username, password database from the environment variable stored in the .env file. This improves security and makes deployment easier. Using these configuration values, we create a ClickHouse client project. Once this connection is established, the same client is used throughout the application whenever the database operations are required. This module only focuses on database connectivity, make it reusable across multiple files. Now, let's look at the core AI module of this project. Here we import the database connection, the Ollama library and the required helper function. The first step is retrieving the database schema. This function queries ClickHouse to collect available tables and their columns. Next, we prepare the prompt for Ollama. The prompt contains two things. First, the complete database schema. Second, the user's natural language question. We send this prompt to the Ollama Llama 3.1. The model analyzes the schema and generates a valid ClickHouse SQL query. Finally, the generated SQL query is written to the Streamlit application. Once the SQL query has generated, it needs to be executed on the database. So, in this file, this function receives the generated SQL. The query is executed using the ClickHouse kind. After execution, we collect both the column names and return the rows. These results are then sent back to the Streamlit interface where they are displayed as a table. This is the main Streamlit application that brings all the modules together. The application first configures the Streamlit page, including the title and the layout. The sidebar displays the database connection and the AI model information. Here, the application accepts the natural language question from the user. When the user clicks the generate button, the application starts the processing. First, it calls the Text-to-SQL module to generate the SQL query. Next, generated the SQL is passed to the executor module. The query runs on the ClickHouse. Finally, the results are displayed in the structural table. The application also provides the option to download the query results as a CSV file. Apart from the web application, I also developed a command line version for testing. This user enters a question through the terminal. The question is sent to the AI model. The generated SQL is executed on the ClickHouse. Finally, the query results are printed directly in the terminal. The SQL scripts. This is SQL scripts creates the internal sales transaction table. It defines the all required columns, data types and table structure need to store the sales data set. And this is analytics queries.sql. This file contains the sample analytical SQL queries that used during the development for testing and validating the ClickHouse database. Now that we have understood how each module works individually, let's run the application and see how all the components work together in a complete end-to-end workflow. From a user's natural language question to SQL generation, execution on ClickHouse and display the results in the Streamlit interface. Let's take a look at the application in action. This is the ClickHouse AI assistant, which allows user to interact with the ClickHouse database using natural language instead of writing SQL manually. First, I will enter show tables. As you can see, the assistant understands the request, generate the appropriate SQL query, execute it on ClickHouse, and display the available tables. And also provide the download CSV button also. Now, let's try a business related question. What is the total sales from internal sales transaction? The assistant identifies the required table, generates the SQL query, executes it, and returns the total sales value. Now, I will ask it show first 10 rows from PYPI table. Here, the assistant generates the query with the limit 10 and displays the first 10 records. We can also expand the generate SQL section to see the exact query created by AI. This demonstrates the complete flow, natural language to SQL, SQL execution in ClickHouse. To conclude, ClickHouse, Ollama Llama 3.1 and Streamlit make it possible to interact with database, using natural language and simplified data analysis. I hope you found this session useful. If you would like to explore the implementation, you can check the GitHub link provided with this video. Thank you for watching. Thank you for your time and interest. Have a wonderful day.